Hello all, welcome to the class on mathematics 9th standard. So this covers both CBSE syllabus and Karnataka state syllabus. Today let's focus on surface area of right circular cone, and this is the first topic of surface areas and volumes chapter. Okay, let's explore the new solid now, the cone. Okay, till now we studied surface areas of cubes, cuboids and cylinders. Okay, and we embark on new adventure, the cone, today. Previously we built solids by stacking congruent figures called prisms. Okay, we built cuboid. So for example, we built cube by stacking the squares. We built the cuboid by stacking the rectangles. Similarly, we built other solid objects, correct, and those called prisms. Okay, now we venture into world of pyramid, something different than the prisms. Okay, a different breed of solids. And have you ever seen a cone in real life? See, look at it. I captured some of the images of the cones, and of course I also captured the images of cubes, cuboids, etc, etc. You get you get to see a different kinds of cones in this diagram in the right side. Okay, in the left side you have spheres, rectangles, I mean other things. Okay, not rectangles, the cubes and cuboids. Now let's make a cone now. Okay, from triangle to the cone in a spin. I mentioned, right, we generally we learned how to make a solid figure from the plane figure. Okay, for example, as I mentioned, we made cube from square, we made cuboid from rectangle by stacking them, of course, right? So now let's see how can we make cone from triangle in a spin. Okay, grab right angle triangle, a string, and of course your imagination. Okay, see this, you have it. Attach a string firmly along one of the perpendicular sides. What is the perpendicular side here? This one, right? You attach a string firmly, okay, along the perpendicular sides. Now what do? Hold the string, hold the string, okay, and spin the string, spin the triangle like a twirling dancer. What you will get to see? What you will get to see is, watch as the triangle magically transforms into a cone. See this image? See this image, you can see it, right? So now the first one was a triangle. When you are spinning it, it's magically transforming into a cone. Now think back to delicious ice cream cones. They are cones too. Look at it, they're cones too, right? So shape. Now I just place couple of some more images just to help you to visualize how we were able to derive the cone from a triangular shape. Okay, now let's meet the right circular cone one level further into the cone. See, we learned, right, we were able to get the cone from the triangle by spinning it. So since we use right angle triangle, and let me call this cone, the resultant cone, as a right angled triangle, right circular cone. We use right angle triangle to make the cone. We call this new cone as a right circular cone. I think very much clear, right? Now, so what I did now here is I have recreated the same image with by mentioning some of the parts of the cone. What are the parts of the cone? Let's see it. First one is the vertex. What is vertex? Vertex is a pointy top where all the edges meet. See, this is a pointy top. This is a pointy top where this side, and this all edges meet here. Okay. The height h. Okay. What is height h? A straight line distance from the vertex to the center of the base. See this? What is center of the base? This is vertex, right? And this is center of the base, right? And you draw a straight line from vertex to center of the base. This distance, this is called height. Okay. And what is radius? The distance from the center of the base. Look at it. This is, you see, the bottom part is circular, correct? So from the center to the edge, the distance is called radius. Of course, you know the radius of a circle, right? This is very similar to that. And what is now slant height is a new word, right? The distance from the vertex. See, what is vertex here? The vertex. This the distance from this vertex to any point on the edge of the base. To any point on the edge of the base. This, okay, or this. We call this as a slant height. See, there is a difference between this height and this height. And this is basically the, altitude. It is a straight line from the center, the vertex to the center of the base. Whereas this slant height is from vertex to the edge of the base. Okay. Now base is a circular face at the bottom of the cone. See, cone has a circular base, right? That circular face is called as base. Okay. Now we explore further. Okay, the cone. So when I say cone, it means right circular cone, unless I mention it is different, or oblique cone. Okay, right, cone. Now be ready now again for a second activity. Scissors at the ready. Be ready. Of course, you come with your imagination. Right now, what is this? It is a cone. Okay, and let us start. Slice a cone neatly along its slant height. What is this slant height? This is slant height, right? This whole thing is slant height, right? Whole thing. Maybe cut this in this portion. Okay. Slice a cone. Now don't cut it like this. Cut it vertically in one place, right? Slice a cone neatly along its slant height to reveal its hidden shape. Now I want to see this. What is inside it? Reveal its shape. Okay. Now it looks like this. We cut it here. Okay, in between A and B, right? Now open it. Unfold the cone. Okay, unfold the cone like this to witness the sector-shaped slice of a paper, like a slice of pizza. Imagine a pizza, a sectored one. Okay. Now what you need to do? Look at it. Imagine cutting this. Now you open the cone, it appears like this. Now just imagine yourself cutting this, sector, the opened, paper, right? A sector into it, hundreds of teeny triangles like this. For example, look at it. 1 triangle, 2 triangle, 3 triangle, like this. 4, 5, 6, 7. These are all triangles, right? Hundreds of triangles, n number of triangles. Imagine. Okay. So now what this entire area is made up of many number of triangles. Okay, and of course, what is the important point to take is what is the height of the cone? Height of the, what is the triangle's height? This triangle EC, this got made up of n number of triangles, right? The triangle's height is same as the cone's slant height. Okay, cone has got slant height, so that is same as this triangle's height. Okay, that's what we should learn it. Now with the formula, what is the area of the triangle? We know it, half into base into height, right? Now what is base here? What is base? This is a base, B1 or B2 or B3, right? For example, in the first triangle, I have a B1 as a base. I have a B1 as a base right here. Okay, half into base B1 into height is what? Length? Sorry, not L, right? Slant height. L. Base of a triangle into base into height. Where height of a triangle is same as a slant height of the cone. So that's the reason I'm writing it as a length. Yeah, sorry, L. Okay. Now let's continue further. Now we learned this cone. This surface area is opened, and this is made up of n number of triangles. each area with the triangle, each area of each triangle is equal to half into base into b1 b2 b3 into slant height. Correct. Let's continue further. This is I took it further, just to I'm marking here. What is r? R is radius of the same cone. Height is altitude or height of the same cone. L is the slant height of the cone. Okay, it's very much clear now. Now let's start from here. Okay, we are interested in finding the surface area or curved surface area of this cone, right? What is the area of the triangle? Half into base into L, we know it, right? Half into base. Base means this small triangles base. Okay, then what is total curved surface area is equal to sum of areas of all the triangles. Sum of areas of all the triangles. And I told you, imagine yourself, okay, slicing this opened surface into n number of hundreds of triangles, right? And now add the areas of all the triangles. Okay, what is this now? First triangle is half into b1 into L. What second triangle? Half into b2 into L. Half into b3 into L. Where L is slant height of a cone or height of the triangle, and b1, b2, b3 are bases of these triangles. Clear, right? Now I can take out L common because L is common in all the places, so I can take out half is also common. I'll take out half outside. I'll take out L outside, and remaining b1, b2, b3 becomes one bracket within a bracket. Now it's clear, right? Now okay, now now b1 plus b2 plus b3, this b1 plus b2 plus this b1, right? Yeah, this b1 plus b2 plus b3, right? What is this? See, look at it. b1, b2, b3, b4, b5, b6, b7, b9, b9, all of them, this whole entire thing is area, right? This whole, sorry, circumference, right? And this, because since base of a cone is circular, I can say it is the circumference of a circle or circumference of a circular base. Then what is the circumference of a circle is 2 pi r. Now I am replacing circumference b1 plus b2 plus b3 up to bn with 2 pi r. Okay, now you see what happens. 2 gets cancelled. 2 gets cancelled, right? Now what we get? Pi rl. This pi rl is the curved surface area of the cone. It means this one, right? Remember. Okay, let's continue. Now we found out the curved surface area. See, remember this cone has got base also, right? This base, and it has to be covered also. Okay, so now to fully cover the base, okay, fully cover the base of the cone, cover the cone, we need a circular piece of paper for the base. Correct? This has to be covered also. This region. This region, right? This region, right? This region. So I need to cover it up, right? So I need a circular piece of paper. Let me see what is the area of it. Now what is the base area? Because it's circular in nature, area of a circle is pi r square, correct? So then pi r square, it's simple. Now I got area of a curved surface here, and I got a area of a circular base here. Now add them to get the total area of the cone. Okay, total surface area is equal to curved surface area plus base area. Okay, that is equal to how much? Pi rl plus pi r square. Pi rl plus pi r square. If you take out pi r common, right? Pi r common, right? Now L plus r square. What is this? Pi r into L plus r is this one. Now what is the summary? Surface area of the cone is equal to pi r into L plus r. Surface area of the cone is equal to pi r into L plus r, where r is the radius of the circular base. Here, r is the radius of the circular base. This one, okay, or this one, okay, and L is slant height of the cone. Remember, this cone has got two heights. One is height, vertical. One is a slant height. Height is altitude or is slant height. I'm talking about slant height here. It means this height and not this height. Okay, so the formula is very clear. Surface area of the cone is equal to pi r into L plus R. So remember now, we are talking, R is very much clear, radius of the base, and we know the formula, pi r square we can calculate. Okay, and so, and we also need a slant height, right, L. And how do you get the slant height is the question now, right? So if height of a, height of a, cone is given, okay, if height of the cone is given, h, and if radius is given, now because it is a right angle triangle, right? So now we can use Pythagoras theorem. Pythagoras theorem states that the square of a hypotenuse, see, because this is 90-degree, correct? The opposite side is hypotenuse. Okay, the square of hypotenuse is equal to squares of other two, sum of squares of other two sides. It means L square is equal to h square plus r square. Okay, now, and you can always calculate, solve, right? L is equal to what? Square root of r square plus h square. Now it's very clear. Okay, now let's do some exercises. Okay, numerical problems to understand it. Let's take some examples. One is, find the curved surface area of a right circular cone. What is that we need to find? Curved surface area, this blue colored one. Okay, of course, whose slant height is given 10 centimeter. The slant height is given 10 centimeter, and base radius is given 7 centimeter. Okay, let's calculate the formula. We know the curved surface area, right? What is curved surface area? Is equal to pi r L. Just now we derived it. Where pi is equal to 22 by 7 or 3.14, you can mention. R is radius of the base. This is a circular base, right? Its radius. And L is height, slant height. Okay, let's substitute them. Simple, right? So what is that? Curved surface area is equal to how much? 22 by 7, of course pi, that into radius is given 7 into 10, right? L is 10, R is 7, pi is 22 by 7. Solving it, see, 7 it goes. Now what is the problem? 22 into 10, correct? Now 220, and you should don't forget to mention the units. Since it is, we are talking about area, the and unit is centimeter square. Okay, so what is the answer? The answer is the total surface area of the cone is equal to 220 centimeter square. Now let's take one more example, example 2. Okay, let's read. The height of a cone is 16 centimeter and its base radius is 12 centimeter. Find the curved surface area and the total surface area of the cone. Of course, you can use pi is equal to 3.14 or 22 by 7, depending on whichever suits your simplifications. Okay. Now let's visualize this question itself. What is given? Height of a cone is given 16 centimeters. Now I say this is vertex to the center of the base. It is 16 centimeter height or altitude, and base radius is also given. So this is the center of the base to the edge of the base. It's called radius, right? 12 centimeters given. Okay. Now what is that we need to find out? We need to find out the curved surface area, this one, okay, and total surface area. Okay, right. What is given? We know it, right? Okay, slant height, curved surface, we need to calculate. Base area, you need to calculate. Now remember to use Pythagoras theorem, because it's not given the slant height. Slant height is not given. Correct. What is required in a formula is pi r. See, curved surface, right? Curved surface is required. Curved surface is what we are looking for, right? Here, curved surface. Curved surface formula is pi r L. R is given, L is not given. Okay, this L is not given. Okay, so then, but height is given. I need to calculate the slant height of it, L, right? How do you find out? Because it's a right angle triangle, we can use Pythagoras theorem. Right, Pythagoras theorem. In the Pythagoras theorem, as I mentioned in the beginning, it's a hypotenuse square is equal to this h square and radius square, right? So L square is equal to h square plus r square. So L square is equal to how much? Substitute them. Height is given 16 square, r is given radius 12 square. Okay, So now L square is equal to how much? 16 into 16, 256 plus 12 square is equal to 144. That is equal to 400. L square is equal to 400. Then what is L? L is equal to square root of 400. That is equal to 20 centimeter. Now we got the slant height. Now we got the slant height. The slant height, now I got it. Okay. So now let's substitute them here. Okay. Okay. What is the formula? Pi RL, right? So that is equal to 3.14 into 12 into 20. Radius is 12, L is 20, we calculated it. Now solving it, how much you get it? 253.6 centimeter. Of course, 12 into 2, 24, 3.14 into 12 into 2, how much? 224. Of course, 240 it becomes, right? 3.14 into 240, you can multiply and you can get the value 753.6 centimeters square. It's clear. Okay, let's continue. Okay, now see, we are able to calculate. So we are able to do this, we are able to do this curved surface area, right? Curved surface area. What else is given? Total surface area we need to calculate, right? Total surface area is equal to what? Total surface area is equal to curved surface area, which I already calculated here, and I need to calculate base area also. Let's do base area now. Okay. What is base area? Base is circular. So naturally the formula is area of a circle, pi r square, right? Base area. That is equal to 2 pi, 3.14 into 12 square. Okay. That is equal to 3.14 into 144 square. Right here. Okay. So that is equal to how much? 452.16 centimeter square. You should know multiplication proper. Then total, you substitute them in total surface area. What is total surface area? Total surface area is how much? Curved surface area plus base area. Curved surface area is pi RL, base area is pi r square. Let's sum them. Substitute and sum. Okay, so that is equal to how much? 1205 plus 0.76 centimeter squares. Why? How I got it? You know it, right? Here. Continue. Let's take one more example. 3. A corn cob. See the figure later. Shaped somewhat like a cone. Imagine a corn. The sweet corn cob. Shaped somewhat like a cone, has the radius of its broadest end 2.1. The radius of the broadest end is 2.1 centimeter, and length or height, you can say that, is 20 centimeter. Length means vertical height, or sorry, the vertical one, the altitude or h is 20 centimeter. If each 1 centimeter square surface area, okay, let me show the image. This is a corn image, right? So this vertical height is given here. How much is that? H, right? So this H is how much? 20 centimeter, of course. And now the broadest area, this broadest area, okay, as a radius, okay. The radius, it says from center, assume it. So radius is, it's given approximately 2.1 centimeter. Now our radius is given. So now each area, assume take a unit centimeter square area. Each area has got a, okay, an average of 4 grains. 4 grains are there in each centimeter square area. Then what we need to find out is how many grains you would find in the entire cob. The entire cob, how many grains you would find. Let's calculate them. Okay. Now, so focus on curved surface, because naturally the cobs grow on surface area, right? Curved surface area, right? Grains only grow on curved part of the cob. Okay. Apply real world context. Surface area concepts have practical applications, remember. Okay, this is what real world application of our chapter. Approximate round off calculations when appropriate. We'll tell it why round off is required. First, list the ground given, then find the slant height, then find the curved surface area, then of course go into solving solution. Okay, And then what is height? Height is given 21 centimeter. Okay, this entire height. Okay. Then length, radius is given to 2.1 centimeter from here to here. Okay, 2.1 centimeter. Length is not given. Length, sorry, slant height is not given. L. Okay, this is, let's close this part first. Okay. Okay, since slant height is not given, we can use the Pythagoras theorem to calculate the slant. We know it, right? Just now. So what is L square is equal to h square plus r square, where L is a this whole side. Okay. So height is given. So it's equal to 2.1 square plus 20 square. Radius is 20. Okay, height is 2.1. Is it correct? No, it's reverse, right? This is radius and this is height. Okay, fine. So then what is that? Radius is equal to how much? So radius is 2.1 square, right? So 4.41 the left part, and 20 square is equal to 400 it becomes. So L square is equal to 404.41. Okay, then what is L? L is square root of 404.41, remember. Okay, that is equal to 20.11. Okay, just fix this part. Okay, it is 404.41. So what is length? Length is equal to 20.11 centimeter. Clear? Sorry, slant height. Slant height is equal to 20.11 centimeter. Now let's go and do calculations for curved surface area. That is, formula is given pi RL. 22/7 pi, radius is 2.1. Of course, in the slant height we just calculated 20.11. Now what is happening? So 7 3s are right, 3.3 it becomes. So 22 into 0.3 into 20.7. See, 7 3 is 21. Remember. Okay. So it becomes 0.3. Clear, I guess, right? So now how much? How much is the value? So 22 into 0.3, 6.6. Okay, into 20.11, 20.11. So that's equal to what? 132.73. So now what we got now is curved surface area. We got it. Okay. Now let's not bother about the base, because it's an real world problem, and we expect nothing grows here, or this is very minimal, right? So base areas I'm not bothered. So now let's get into the next part of the problem, which is to calculate, okay, how many grains you would find in the entire crop. What is given here is the number of grains on the corn per 1 centimeter square is 4. It is given. In this, per centimeter square of the cob, you will get to see 4 grains. And we need to calculate total number of grains in the entire surface area, right? So the number of grains on the entire curved surface of the cob is equal to how much? So now this one, okay, this is total surface area, correct? Total curved surface area divided by 4. It's divided by 4. Okay, that is equal to 530.92. Yep, correct. Sorry, it is into only. Okay, okay, so we have got we have got 4 grains in 1 centimeter square. So totally how much we get in 132.73 square centimeter, right? So that is equal to multiplication 530.92. Approximately we say 531 grains in the entire surface area. Okay, this is an answer. So there would be approximately 531 grains of corn on the cob. This is, we find an answer. Now let's close this for now and continue the second part of the surface areas and volumes in the next class. Thank you.